Hello, hi everyone. Welcome to the Stone the Brand. So this is our Siva sir. Today we are going to discuss about scalars and vectors, scalars and vectors. So before that, so we have to discuss about quantity and physical quantity. After that, we will discuss about scalars and vectors. Now, if you go to shop, okay, so like any grocery shop, if you go to that shop and ask, I want rice, I want a dal, I want chocolates, so I want like, okay, so if you ask the shopkeeper, immediately the shopkeeper will ask two questions: for how much, and for how much and how many, they will ask. Okay, for a how many, for a how much, and how many you want, right? So here the answer for how much or how many, the answer for how much or how many, or it is a quantity, it is a quantity or vastness or magnitude. So if you take magnitude, quantity is nothing but magnitude, vastness. Okay, so like that we are saying that is the quantity. So coming to the physical quantity. So what is physical quantity? The quantity which can be measurable. The quantity which can be measurable is called physical quantity. So suppose weight of the object, so weight of the table, weight of the marker. Okay. So distance traveled by an object, speed with respect to time. Anyway. Okay. So speed we can measure, distance we can measure, mass we can measure. Okay. And weight we can measure, right? These are all physical quantities. Means the quantity which can be measurable. The quantity which can be measurable is called physical quantity. And here there are, here especially topic especially related to scalars and vectors, so we will discuss about these two physical quantities. One is scalar, another one is vector. So scalar is a physical quantity which have only magnitude. The physical quantity which have only magnitude, that is called scalar physical quantity. And coming to the vector physical quantity, the physical quantity which has both magnitude and direction. So the physical quantity which has both magnitude and direction, that is called vector physical quantity. So scalar physical quantity means the physical quantity which has only magnitude, only magnitude. It has only magnitude. Suppose you can take distance, speed, mass, volume. These are all physical quantity which has only magnitude, like 2 meter, 3 meter, 4 kg, 5 kg, 6 kg, 3 meter per 3 kg per meter cube volume, 4 kg per meter cube, like that. Okay. So these are all examples for scalar physical quantity. Coming to vector physical quantity. The quantity which has both magnitude and direction. Both magnitude and direction. Suppose you take displacement. Displacement has both magnitude and direction. Yes or no? So 2 meter per second, armor, particular direction. And velocity and acceleration, momentum, linear momentum. Okay. So these are all examples for vector physical quantity. Simply we can say vector quantity. Understood? Now we will discuss about types of vectors. We will discuss types of vectors. Okay. So scalars and vectors introduction over. Now we will discuss about types of vectors. Types of vectors. Ready? Types of vector. Types of vectors. So first one is equal vectors. Equal vectors. Equal vectors. Equal vectors. Second one is negative vectors. Negative vectors. Negative vectors. Coming to third one, unit vector. Unit vector. Unit vector. So fourth one, null vector. Null vector. Or zero vector. Zero vector. So fifth one, co-initial vector. Co-initial vector. Co-initial vectors. Next one, collinear vectors. Collinear vectors. Collinear vectors. Coming to seventh one, coplanar vectors. Coplanar vectors. And eighth one, orthogonal unit vectors. Orthogonal unit vectors. Orthogonal unit vectors. Orthogonal unit vectors. Coming to ninth one. So localized vector. Localized vector. Coming to 10th one, non-localized vector. Non-localized vector. Okay. So here, these are the vectors types of vectors. So one by one we will discuss. One by one we will discuss. Still, so position vector, and hi Devanshu, hi. Position vector and displacement vector, like that it is there. So we'll discuss one by one. Equal vectors. Equal vectors are nothing but the vectors having equal magnitude. The vectors having equal magnitude and having same direction. Both vectors having equal magnitude at the same time, both are acting in the same direction. Then we can say those vectors are equal vectors. Coming to negative vectors. Negative vectors. So here you can observe equal magnitude. The vectors having equal magnitude but acting. So the vectors having equal magnitude but acting opposite to each other. Opposite to each other. Okay, so those are negative vectors. Coming to unit vector. So unit vector, here you can observe unit vector. Unit vector. Unit vector. Suppose I'm taking a bar equal to, okay, so ax I cap plus ay j cap plus az k cap. Okay, so I will explain what is I cap, j cap, k cap. So a bar if you are taking, okay, so if you want to find out unit vector, so we can take a cap. Unit vector is represented with a cap. Okay, so here A cap equal to A bar by mod A bar. A bar by mod A bar. So AX I cap AY J cap plus AZ K cap by so root over AX square plus AY square plus AZ square. So if you're taking the magnitude, if you want to find out the magnitude, okay, so you have to take root over AX square plus AY square plus AZ square. Understood? Unit vector. Unit vector is represented with A cap. Unit vector is represented with A cap. So here you can observe unit vector. Unit vector. Okay. So here you can observe here unit vector. A bar is the unit. A bar is the vector. A bar is the vector. AXI cap, AYJ cap, AZK cap. Okay. So this portion. Normally also we can take A bar equal to 2I cap plus 3J cap plus 4K cap also. 2I cap plus 3J cap plus 4K cap also we can take. Okay. So we can also take here 2I cap plus 3J cap plus 4K cap. So instead of AX, AY, AZ, we can take numbers also. We can take numbers. Understood or not? Okay, here you can observe. So unit vector A bar equal to AXI cap, AYJ cap, AZK cap. So A cap is a unit vector. Unit vector is represented with A cap. Unit vector is represented with A cap. A cap. So A cap equal to A bar by mod A bar. Mod A bar is the magnitude. Okay, so only magnitude. To find out the magnitude, we can take root over. So here AX, AY, AZ, right? So that's why I'm taking root over AX square plus AY square plus AZ square. Okay, so root over AX square plus AY square plus AZ square. So that's why we are taking this one. Understood or not? Understood or not? I hope it is very clear. I hope it is very clear. Right? Yes. So unit vector is represented with A cap. Unit vector is represented with A cap. A cap. So A bar by mod A bar. So this the magnitude. To find out the magnitude, suppose one example I'll give. So I'll give an example. Suppose I'm taking A bar equal to 2I cap plus 3J cap plus 4K cap. 4K cap. Okay. So if you are taking magnitude, so if you want to find out the magnitude, root over 2 square plus 3 square plus 4 square. Okay. So you have to find out the values. 2 square is 4, 2 square is 4, 3 square is 9, 6 square, 4 square is 60. So root over 29. Root over 29. Understood? Like that we can find out magnitude. Like that we can find out. Understood or not? Once again, if you are taking A bar equal to AXI cap plus AYJ cap plus AZK cap. Okay, so we can also take with the help of numbers also. 2I cap plus 3J cap plus 4K cap. So A cap is a unit vector. A cap is a unit vector can be represented. So A bar by mod A bar. Mod A bar is represented. So normally vector we have to write as it is. AXI cap, AYJ cap, AZK cap. Okay, so I'll explain. So when it comes to the resolution of the vector, that time I will explain this point. So keep in mind. Okay, root over ax square plus ay square plus az square. Okay, so magnitude. This is the mod. Normally, we can also take a bar equal. Mod a bar is also can be written simple a. Okay, simple way we can write. Understood or not? Mod a bar is equal to a only. There is a magnitude only, right? So we can write like this also. Understood? So that is a unit vector. That is a unit vector. Now, so we'll discuss about null vector. Null vector. Null vector is represented the vector whose magnitude is zero. The vector whose magnitude is 0. Okay, so here you can see the vector whose magnitude is here, unit vector can be represented a cap equal to a bar by mod a bar. Understood? Like, so a null vector, or simply we can say unit vector. Null vector, unit vector. The vector whose magnitude is 0. The null vector whose magnitude is 0, that is called null vector. Coming to co-initial vectors. Co-initial vector. Okay, coming to co-initial vector. The vector whose initial point is fixed. So here, the vector whose initial point is fixed, that is called null vector. Oh, sorry. The vector whose magnitude is 0, that is called null vector. The vector whose initial points are fixed. If you are taking here, this is a bar and a b bar. So angle is theta. So initial point is fixed. Initial point is fixed. These are co-initial vectors. Initial point and okay. Next one, collinear vectors. Collinear vectors. The vectors are acting in the same direction. Okay, in the same plane like this. In the same direction. In single line. Coplanar vectors. Here, the vectors are acting in the same plane, xy plane. So if you are taking here, so vectors are acting in the same plane. So irrespective of magnitude and direction. Coming to orthogonal unit vectors. Orthogonal unit vectors. Here it is very, very important. Here it is very, very important. So we know, just now we discussed about x-axis, y-axis and z-axis. X, Y, Z. Okay, X, Y, Z. Right? So along x-axis, I cap is the unit vector. Along y-axis, j cap is a unit vector. Along z-axis, k cap is a unit vector. Okay. The magnitude of I cap, j cap, k cap is 1. Okay. So magnitudes of I cap, j cap, k cap is 1. Because these are all unit vectors. I cap, j cap, k cap are the unit vectors. Are unit vectors. Their magnitude is 1. Their magnitude is 1. Coming to the localized vector. Coming to localized vector. The vector whose initial point is fixed. So initial point is fixed. That is called localized vector. The vector whose initial point is not fixed. Okay. So this vector initial point is fixed. Initial point is fixed. Initial point is fixed. And here initial point is not fixed. Initial point is not fixed. Okay. So I hope it is very clear. Once again, so here observe equal vectors, negative vectors, unit vector, null vector or zero vector. Null vector or zero vector. Coming to co-initial vectors, collinear vectors, coplanar vectors, orthogonal unit vectors, localized vector, non-localized vector. So equal vectors. So vectors having equal magnitude and having same direction. So two vectors having equal magnitude at the same time, both are acting in the same direction. So those vectors are called equal vectors. Coming to negative vectors. So vectors having equal magnitude, but those are acting opposite to each other. Okay, equal magnitude, but acting opposite to each other. Those are called negative vectors. Coming to unit vectors. Unit vectors, I'll give an example for unit vectors. Okay, so we'll do examples with the help of unit vector. So unit vector A cap is A bar by mod A bar. We'll do some problems. So some examples related to unit vector, then you'll get to know. So null vector, the vector whose initial vector magnitude is 0. So vectors having zero magnitude. Okay, that is called null vector or zero vector. Coming to co-initial vectors. So vector initial point is same. Vectors initial point is same. That's why it is called co-initial vectors. Coming to collinear vectors. Vectors are acting in the same direction, the same line. So A bar, so this is the B bar. Acting in the same direction. That's why collinear vectors. Coming to coplanar vectors. Vectors are acting in the same plane. Next one, orthogonal unit vectors. So along x-axis I cap, along y-axis j cap, along z-axis k cap. I cap, j cap, k cap are the unit vectors are acting along x, y, z. I cap along x-axis, j cap along y-axis, k cap along z-axis. Coming to localized vector. So coming to localized vector, the vector initial point is fixed. The vector initial point is fixed, that is called localized vector. Coming to non-localized vector, the vector whose initial point is not fixed. The vector whose initial point is not fixed is called non-localized vector. Non-localized vector. I hope it is very clear. Understood or not? So now, so we'll discuss few more points. So position vector, position vector. So we'll discuss. So next one is 11th position vector. Position vector. So position vector is nothing but, okay. So here I'm taking this x-axis and y-axis. This is x-axis and y-axis. Position vector. Understood? This is the position vector. So this is the vector A. So this is the coordinate axis. So origin. So with respect to coordinate x-axis and y-axis. So from origin, if you want to represent this vector, so this is the position vector. Position vector. Okay, to represent this vector, so A cap is the vector, A bar is the vector, A bar is the vector. Understood? Okay. Okay, so next one, 12th one is displacement vector. Displacement vector. Displacement. Displacement vector. Okay. So here you can observe. So here I'm taking along x-axis and y-axis. This is x-axis and y-axis. So here position, so this is A bar. So this is from origin, or from origin is R1 bar, and this is B bar. This is a B bar. This is from R2 bar. Then if you are taking here, this is the displacement vector. Displacement vector. Understood or not? So delta R bar, that is nothing but R2 bar minus R1 bar. Okay, displacement vector. This is the displacement vector. I hope it is very clear. Displacement vector. Displacement vector. Displacement. Displacement vector. Is it clear? So I hope it is very clear. Just check once. Just check once. These are the types of vectors. These are the types of vectors. So I hope it is very clear. Next one, addition of vectors. So we'll discuss about addition of vectors. Addition of vectors. There are three laws are there regarding the addition of vectors. Addition of vectors. Addition of vectors. First one is triangle of vector. Triangle law. Triangle of vectors. Coming to the second one, parallelogram law of vectors. Parallelogram law. Coming to third one, Polygon law of vectors. Polygon law of vectors. Understood? So addition of vectors. So before we discussed, so types of vectors. Types of vectors we discussed. Now we are discussing about addition of vectors. After that, we will discuss about product of vectors. That is about dot product and cross product. That we will discuss. Now we are discussing about addition of vectors. Okay. Coming to triangle of vectors. Triangle of vectors. Okay. Triangle of vectors. Triangle of vectors. So triangle of vector is nothing but two vectors are acting along the two sides of the parallel, two sides of the triangle. So I'm taking A bar and B bar. A bar and B bar acting along the two sides of the triangle. The resultant is acting opposite. The resultant is acting opposite of these two vectors. So C bar. Then C bar equal to A bar plus B bar. So observe carefully. Triangle of vector is nothing but, so two vectors are acting along the two sides of the triangle and the resultant is acting opposite to of remaining two vectors. Okay. This is the triangle of vectors. Understood? So I hope it is very clear. So coming to the parallelogram of vectors. So parallelogram is little lengthy. So still we will discuss about it. Parallelogram of vectors. Parallelogram of vectors. Parallelogram of vectors. Parallelogram law. So here two vectors acting along the two sides of the parallelogram. So observe carefully. So I'm taking here. So A bar is acting and B bar also. This is the B bar and A bar. The angle between A bar and B bar is, the angle between A bar and B bar is theta. Angle between A bar and B bar is theta. Understood? And so we are drawing. The resultant is acting. The resultant is acting diagonal of two vectors bisecting the angle. Bisecting the angle. So I'm drawing parallel to this one and here also. Okay, so this is the resultant, R bar. So two vectors are acting along the two sides of the parallelogram. The resultant is acting diagonal of those two vectors. That is the resultant. Understood? So now draw parallel lines, okay, along x-axis and y-axis. I am drawing like this, and here also. So this the theta, x and y. Okay, so this is parallel to A bar and parallel to B bar. So this is the right angle triangle, right? Right angle triangle. So take this right angle triangle, that is here B magnitude, here is theta, x-axis, x-axis, y-axis. Okay. So cos theta formula. Cos theta equal to adjacent side by hypotenuse. Adjacent side is B, hypotenuse is, adjacent side is X. Hypotenuse is B. Adjacent side is X, hypotenuse is B. So X equal to B cos theta. X equal to B cos theta. And coming to the sin theta formula. Sin theta equal to opposite side by hypotenuse. Opposite side is what? B. Hypotenuse is what? So opposite side is y, hypotenuse is b. So y equal to b sin theta. Y equal to b sin theta. Is it clear? Is it clear? Once observe here. Once observe. Okay, right angle triangle. So we consider cos theta equal to adjacent side by hypotenuse x by b. X equal to b cos theta. Sin theta is equal to opposite side by hypotenuse. Sin theta is equal to y by b and y equal to b sin theta. Now, so we know from Pythagoras theorem. So Pythagoras theorem, that is r square. So here I'll write r square equal to here a plus x whole square plus y square, right? So a plus x whole square plus y square. All right. So we know a plus b whole square formula. So a plus b whole square formula, that is a square plus b square plus 2ab. A square plus b square plus 2ab. Yes or no? From here r square equal to a plus x is nothing but b cos theta. X is nothing but b cos theta whole square plus y square is nothing but b sin theta whole square. Okay. So from trigonometric identities, sin square theta plus cos square theta equal to 1. Yes or no? Sin square theta plus cos square theta equal to 1. So that's why r square equal to a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. B square sin square theta. Okay. So from these two terms, so b square sin square theta, b square cos square theta. From these two terms, we can take b square common. Then r square equal to a square plus b square common. So anyway, cos square theta plus sin square theta plus cos square theta is same. So 2ab cos theta. So from this, you can observe cos square theta plus sin square theta plus cos square theta equal to 1. So then we can write r square equal to a square plus b square plus 2ab cos theta. Understood? So r equal to root over a square plus b square plus 2ab cos theta. Understood or not? So r equal to a square plus b square plus 2ab cos theta. I hope it is very clear. Understood or not? Just check once. Just check once. Scalars and vectors. Parallelogram law. Okay. So parallelogram of vectors. Parallelogram of vectors. Parallelogram vectors. Understood? So two vectors are acting along the two sides of the parallelogram. So here A bar, B bar are acting along the two sides of the parallelogram. The resultant is acting diagonal of these two vectors. So extend this vector along the x-axis and this the y-axis. So theta, angle between x-axis and vector B bar, theta is here. And now from this one, this right angle triangle, so cos theta equal to adjacent side by hypotenuse. So x equal to b cos theta, sin theta equal to opposite side by hypotenuse. So sin theta equal to y by b, y equal to b sin theta. Okay. So we know from Pythagoras theorem, Pythagoras, according to Pythagoras theorem, so hypotenuse square equal to side square plus side square. Your hypotenuse square is nothing. So square equal to a plus x whole square plus y square. A plus x whole square plus y square. Understood? That's why r square here x is what? B cos theta. X equal to b cos theta. And y equal to b sin theta. Substitute here. Then you'll get, so after solving, anyway, here from this two, we know a plus b whole square formula, a square plus b square plus 2ab sin square theta plus cos square theta equal to 1. So we can take, so we can write this identity is 1. Then r square equal to a square plus b square plus 2ab cos theta. R equal to root over a square plus b square plus 2ab cos theta. I hope it is very clear. So this is about parallelogram law. Parallelogram law, right? So next one we will discuss about polygon law of vector. Polygon law of vectors. Okay, polygon law. So let's start discuss about polygon law of vector. Okay, polygon law of vectors. Polygon law of. So what is polygon law? So vectors acting along the sides of the polygon. So here A bar and B bar and C bar and D bar and E bar. So the vectors, the final vector, the resultant is acting E bar and the resultant is acting opposite to of all the vectors. Okay, that is F bar. Okay, so F bar equal to A bar plus B bar plus C bar plus D bar plus, okay, A bar, B bar, C bar, D bar. Observe, so F bar equal to A bar plus B bar plus C bar plus D bar plus E bar. Understood? So this is a resultant vector. So F bar equal to A bar plus B bar plus C bar plus D bar plus E bar. Understood? So that is about polygonal vectors. Coming to resolution of vector. Resolution. How we can resolve vector along x-axis, y-axis and z-axis. Along x-axis, along y-axis and along z-axis. How we can do that? So we'll discuss now. Okay. So resolution of vector. Resolution of a vector. Okay. So here you can observe I'm taking x-axis and y-axis. Along x-axis, y-axis. So this is the A bar vector. A bar is the vector. A bar is the vector. So we have to resolve that vector into components along x-axis and y-axis. Okay, so here A bar is making certain angle with x-axis. So here you can take along x-axis and along y-axis. So suppose you are taking x and y, this is A. So same you are taking here. So previously I took like this, right? So this is the theta, this is A and x, y. Resolving the components. Now cos theta equal to, what is the formula? Adjacent side by hypotenuse. Adjacent side by hypotenuse. So x equal to A cos theta. And coming to sin theta equal to y by A. Opposite side by hypotenuse. Opposite side by hypotenuse. Y equal to A sin theta. So now along x-axis, so A bar component is A cos theta, vector component. A bar component is A cos theta. Along y-axis, A bar component is A sin theta. So A cos theta and A sin theta. Understood? So now we can consider A bar equal to A bar equal to, so Ax I cap plus Ay j cap. So as I mentioned, I cap j cap are the unit vector along x axis and y axis. So Ax is nothing but A bar equal to A cos theta I cap and A sin theta j cap. Okay. So if you take magnitude, so A bar mod A bar equal to, that is equal to A. How you will get, you see, A cos theta whole square plus A sin theta whole square. Right? So we know cos square theta, sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta 1. So that's why here root over A square we can take common. Sin square theta plus cos square theta plus 1. So root over A square, that is A. So now magnitude of A bar equal to A. Magnitude of A bar is A. Understood or not? I hope it is very clear. I hope it is very clear. Right? Yes. So now, so directional cosines of a vector. Directional cosines of a vector. Okay. Directional cosines of a vector. So let's start here. Directional direction cosines of a vector. So here you can take y-axis, x-axis, and z-axis. So this is the vector. A cap is the vector. A cap is the vector. A bar is the vector. Okay, not A cap is the unit vector. A bar is the vector. A bar is the vector. Okay, A bar is making angles with x-axis, y-axis, and z-axis. This is x-axis, y-axis, and z-axis. A bar is making with x-axis alpha. A bar is making with z-axis beta. So A bar is making with z-axis gamma. Okay, directional cosine. So now, so previously I said along x-axis, along y-axis, along x-axis, what you are taking? Cos alpha. Cos alpha equal to ax by a. That is nothing but mod a. Okay, cos beta. Cos beta equal to ay by a. Okay, cos gamma equal to az by a. Az by a. Right? So now a cos square alpha plus cos square beta plus cos square gamma. Okay. So cos square alpha plus cos square beta plus cos square gamma. That is, so substitute here ax by a whole square plus ay by a whole square plus az by a whole square. Then that will get, so ax square plus by a square plus ay square by a square plus az square by a square. So ax square plus ay square plus az square. A square equal to root over. So a square equal to ax square plus ay square plus az square. So magnitude you are taking root over ax square plus ay square plus az square. Before we took to find out the magnitude, we use this formula. So here also finally a square by a square. Then you'll get a1. So a square cancel. Then you'll get cos square alpha plus cos square alpha plus cos square beta plus cos square gamma equal to 1. That is the answer. So very, very important. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Is it clear? Is it clear? Right? Yes. So now product of vectors. Now product of vectors. There are two types of vectors. One is dot product, another one is cross product. Dot product and cross product. So now product of vectors, product of vectors. There are two types of product of vectors. One is dot product, or scalar product. And coming to second one is cross product or vector product. Cross product or vector product. Vector product. So check once here. So dot product or scalar product, cross product or vector product. Vector product. So dot product of two vectors is equal to product of their magnitude and cosine angle between them. Okay. Once again. So we'll discuss about dot product. Dot product first. So product of vectors in that. So we'll discuss about dot product. Dot product of vectors. Dot product or dot product or scalar product. Scalar product. Scalar product. Dot product or scalar product. So dot product of two vectors is equal to a bar dot b bar equal to ab cos theta. AB cos theta. Okay. So if you are multiplying I bar equal to j bar equal to, so k bar equal to 1. So if you multiply I bar equal to k bar equal to k I cap equal to 0. Because perpendicular to each other, right? So along I cap x axis, along y axis j cap, along z axis k cap. Along z axis k cap, right? So that's why along z axis k cap. K cap. So we know dot product of two vectors. So cos 0 1, cos 90 0. Okay, cos 0 1, cos 90, cos 0 1, cos 90 0. That's why. So that's why similar same unit vector if you multiply you'll get 1. Anyway, magnitude is 1. Okay. So if I'm taking example a bar equal to 2I cap plus 3j cap plus 4k cap and b bar equal to, so 3I cap plus 4j cap plus 2k cap. If you multiply these vectors a bar dot b bar, so you have to multiply with the I cap dot I cap. That is 2 into 3 plus 3 into 4 plus 4 into 2. Remaining all becomes 0 because, so as I mentioned, I cap dot j cap dot k cap dot I cap equal to 0. If you multiply I cap dot I cap dot I cap, j cap dot j cap, k cap dot k cap, you'll get the values. So here 6, 12 plus 8. How much? So 26. 20 plus 6, 26. Is it correct? So A bar dot B bar. So we got magnitude. That's why. So it is a scalar physical quantity. Sorry, it is a scalar product. It is a scalar product. That's why it is a scalar product. Understood or not? I hope it is very clear. Next one we will discuss about cross product. Cross product. cross product. Let's start discuss about cross product. Cross product or vector product. Cross product or vector product. Vector product. Cross product or vector product. A bar dot A bar cross B bar equal to AB sine theta n cap. N cap is the unit vector. N cap is the unit vector. So cross product of two vectors is equal to product of their magnitude and sine angle between them. Okay. So n cap is acting perpendicular to the two vectors. Two vectors. That is a cross product. Cross product. Okay. So if you are taking this A bar and B bar, the cross product of A bar and B bar, that is n cap. So yeah, A bar cross B bar acting perpendicular to n cap A bar and B bar. Understood? So now if you want to find out the dot cross product of two vectors, so I'll write how to find out cross product of two vectors. Okay, so here A bar equal to AXI cap, AY j cap plus AZ k cap. Then B bar equal to BXI cap plus BY j cap plus BZ k cap. So A bar cross B bar equal to, so you have to take I cap, J cap, K cap. Then you have to write, so AX, AY, AZ, because A bar cross B bar. A bar cross. So that's why we have to take A. So BX, BY, BZ. So if you are taking B bar cross A bar, then you have to take B bar first, then A bar. Now we have to take, so we have to take 2 by 2 matrix. 2 by 2 matrix. That is I cap you have to take. Then you have to multiply AY, BZ. AY, BZ minus BY, AZ minus J cap. So you have to take again. So AY, BZ, BX, AZ. Okay, so you have to leave horizontal and vertical. Okay, so this is the vertical and horizontal. Remove that columns and multiply remaining 2 by 2 matrix. So AZ. So you have to remove this one and this. Just you have to keep like this. Then what are the remaining? So AX, BZ minus BX, AZ plus K cap. Then AX, BY minus BX, AY. Okay. So even if you are taking values also, similar method you have to follow. Similar method you have to follow if you are taking the values. So instead of this one, you can take 2i cap, 3j cap, 4k cap. So finally you will get in the form of vector. Finally you will get vector form only. That's why it is a vector product. Cross product or vector product. Cross product or vector product. Okay, so one example will do it. One example. So I'll take one example and do. So let's start. Okay. I'll take one example. So A bar equal to 2I cap plus 3J cap plus 4K cap. B bar equal to 4I cap plus 3J cap plus 2K cap. Okay. So find out A bar cross B bar. A bar cross B bar. We have to find out. We have to find out. For that, so what we have to take? I cap, J cap, K cap. So 2, 3, 4, 4, 3, 2. Now, so I cap I'm taking a common. So you have to take 2 by 2 matrix. This is a 2 by 2 matrix. So 3, 4, 3, 2. Okay, you have to take this matrix. So 3, 2 just 6. So 3, 4 just 12. So 6, 12 minus J cap. So I have to remove this one, horizontal and vertical, then 2, 2, 4, 4, 4, 16 plus K cap. Then you have to remove vertical and horizontal. Then 2, 3 ja. How much? 6 minus 12. Then how much? Minus 6 I cap plus here J 12. So 12 J cap. 12 J cap will get 12 J cap. Yes or no? 16 minus 4, 12. So minus 12. So you can get. And here minus 6 K cap. So here you can observe A bar cross B bar. A bar cross B bar is a vector. So it is a vector. So yes or no? This is a vector only, right? That's why it is a vector product. That way it is a vector product. Is it clear? So A bar cross B bar is a vector product. Understood or not? Understood or not? Is it clear? Do you have any doubts? So that's enough. This is about vectors and their products. So thank you so much. If you like the content, if you like the channel, please do like, share, and subscribe to Student the Brand. If you like the channel, if you like the content, if you like the explanation, so do like, share, and subscribe to Student the Brand. Inform to your friends, ask your friends to join to the class, and share to everyone. So thank you so much for joining and attending and listening my class. This is our Seva sir from Student the Brand. Do like, share, and subscribe to Student the Brand. Thank you so much.